Hi, I'm Sundar. I will be your NX and ACI instructor. I welcome you all for this demo course on DCNX and DCACI on behalf of the PyNet labs. Now the agenda of this demo course will be to see what could be the takeaway in terms of the technical understanding as well as from the course benefit point of view. For the course, we will deal with DCNX and DCACI. So I will explain why we need to take these courses together, how the DCNX will influence your learning and understanding of the DCACI. To talk about it generally, the ACI itself is based on the Nexus hardware. So we will explore from the very basics. We will start from the ground up to learn about the Nexus first, and then we will jump into the ACI. Therefore, we can maximize our understanding on these techniques and topics. Moving on. First, DCNX. So I'm going to cover what we will learn about the Nexus, which is here. We will start from the very basics, the hardware. So we will learn about the Nexus 7 case, the Nexus 9 case, how they are different, what is the the VDCs that are supported by the Nexus 7 case, and the 9 case in detail, because the 9 case are those that support the ACI. No other type of the Nexus supports the ACI, so we will have more emphasis on the Nexus 9 case. So we will see the differences at the hardware level by comparing their supervisors and how their FIB and the RIB works. So we will do all those. Now apart from that, once having understood about the hardware of the Nexus switches, we will jump into layer 2 technologies. We will start from port channel. What are the merits and what are the cons of the port channel, and why do we have a virtual port channel? So we will talk about the configuration of this virtual port channel and how to troubleshoot this virtual port channel. And later on, after understanding the virtual port channel, we will also learn about the layer 3 routing configurations being done in the Nexus switches. So we will start from layer 2, we will gradually move towards layer 3, and while we have understood layer 3, we will learn about the FHRP to protect your gateway and to provide redundancy. So having got a very good understanding on the Nexus switches hardware and its layer 2 and layer 3 functioning, that's when we will step into VXLAN. Now I mentioned earlier that understanding of the Nexus hardware is very important for you to understand the ACI, because the ACI, a software defined networking solution from Cisco, is based on top of the Nexus hardware. Likewise, the working of the ACI is also based on VXLAN. Now VXLAN encapsulation is done in the ACI fabric. This is an integral part in the ACI. Therefore, we will learn about how VXLAN works and how the configuration is made with the help of Nexus switches. We also have labs based on VXLAN. So we will learn about the various functionalities, how it supports the extension of the layer 2 domain. Now in fact the name itself is Virtual Extensible LAN. And we will explore why VXLAN is better when compared with VLANs, and how the encapsulation is being done, how the TEP configuration is made, what are the various interfaces we have in the VTEP device. Having a solid ground understanding on VXLAN, we will compare that with the Cisco's OTV to understand why VXLAN could be preferred over the OTV. Now, if you understand VXLAN, you will be able to work with ACI better, because in ACI, everything is based on the VXLAN. The internal traffic is based on VXLAN. So in order to understand VXLAN, you also need to learn about multicast, because in VXLAN the data plane and the control plane are segregated, and the way the control plane works, it has two methodologies. Number one is flood and learn, simply like a head-end replication, and then you can have a multicast infrastructure on which the VXLAN works. So it becomes paramount for us to understand how multicast works. The multicast is used in flood and learn. Then we will learn MP, BGP, EVPN. Now that is again a different control plane of the VXLAN, because multicast is not preferred always. So when you don't want multicast but you still want to achieve a control plane for your VXLAN, we will go for MP, BGP, EVPN. So we will learn about these things. Now the MP, BGP, EVPN can be very useful for you to deal with the ACI's multi-pod and multi-site scenarios, because the control plane used in multi-pod and multi-site scenarios of ACI is again MP, BGP, EVPN. So once we have understood about the Nexus in detail, such as its hardware, layer 2, layer 3, and data center interconnect technologies such as VXLAN and how its control plane work, then we have a solid ground to learn the ACI. Moving on. For the DC ACI, we will start from the ground up, again with the hardware, how the topology architecture is, and various supported architectures. We will explore all those things. For example, the architecture is a collapsed leaf over spine, leaf and spine architecture that is used here. However, we have different types of topologies such as a multi-pod and multi-site. And the hardware, again Nexus. So we will discuss in detail about the hardware and what is the hardware that is more suitable to be spine and the leaf. Now, apart from this, we will deal with a special hardware called apic, Application Policy Infrastructure Controller. Now this controller is the brain, I would say, of the ACI fabric, because it is a software-defined networking solution, and everything, all the policies are being pushed via the apic to the fabric. But this only sits in the management plane, so it has nothing to do with your data and control plane. So we will see how the apic is to be connected, what hardware the apic is working on, where this appliance is present, and what are the precautions, what are the prerequisites with respect to the apic, and what is the cluster details, what is sharding. Sharding is actually how the database in apic is present. So we'll discuss in detail about the apic. If we have completed this, then it means we have a solid ground on the apic hardware. After this, we will step into the configuration and policies. First among that would be the fabric discovery. As soon as you have configured the apic with the initial configuration, the fabric discovery can take place. This is very similar to power on auto provisioning, so the process is mostly automatic, I would say, except that you would be required to intervene just once, which is called registering the node. It's like providing an acknowledgement to the inclusion of the specific node in your fabric. After the fabric discovery, you would readily provide the fabric policy, and then the access policies. The access policies are those that are configured at the access port so that the endpoints can access your ACI fabric. So these are some of the important policies, the fabric policies and the access policies. After this, we will discuss about the constructs such as tenants, application profiles, EPGs, and also VRFs, BDs, and subnets. We will discuss them in detail so as to understand what are the various configurations and optimizations that could be performed in the ACI with the help of these. Say for example, we have an option called layer 2 unknown unicast it's under the BD. Now you can set this to flood or you can unicast this. Generally in a traditional network the layer 2 unknown unicast is flooded, but here in ACI you can make it as a unicast, which means the way that the packets flow it could be modified, altered in ACI fabric. Now that is one thing we would explore in detail. Packet path, packet switching, and packet forwarding in ACI. That is one thing we will go into detail, because all the configurations are aimed at the connectivity and optimization of the packet path. So we will see that. Then we will also see what are the various domains that could be integrated with the ACI fabric. We will see how an existing layer 2 could be connected, how an existing layer 3 should be connected, how route leaking could be done in the ACI fabric, how can you integrate a virtual domain into the ACI fabric. Now those are many things. And finally we will end up with the management and monitoring of the ACI fabric. Now this is only an overview of what we are supposed to deal with. Suppose let's say if you talk about the access policies, for example, now then we have the switch profile, switch policies, leaf profile, leaf policies, leaf interface profile, leaf selectors, leaf interface selectors. So it's a combination of many things. It's a combination of many things so that you can group them together and make use of it again and again. Now this provides agility for us because we can reuse that, therefore we reduce the time that is consumed to deploy the particular configuration. Now, so we have got an understanding of what we are going to deal in the DCNX and the DC ACI. So we had an overview of this DCNX and DC ACI. Now that's the course contents, what we are going to learn. What do you exactly have in the course content? You have 17 sections. Now during the demo I might have left one and two here and there, but you have 17 sections that talks in detail about the Nexus from the ground up. After completing on the Nexus, you will move towards the ACI. Now, apart from these sections, you have 21 labs. So we have the lab environment where we will be performing these labs. Now in the part of the demo, I will also showcase you how the ACI labs is being done. We have labs step by step, gradually built from the ground up labs to make you understand clearly how or what is the best way to make the configurations for the deployment in ACI. Apart from this, you also have 24/7 for the lab access, and you also have a lifetime Telegram channel access wherein you can ask your doubts, get your doubts cleared. So these are the benefits that comes with the course. Now let's jump into the lab. So here is our lab environment. What you see is the apic GUI login page. For the labs, we will make use of EventG in order to accomplish the NX-OS related configurations and learning. However, for the ACI apic, we have this apic wherein we will configure our policies. Now I'm going to log into the apic. Now this is the dashboard. I'm going to take you to the, as you can see in the screen, you see we will be making use of the 5.2 version of the apic. Now this is a more recent version for the apic ACI. So I'm going to take you to the topology first. So go to the fabric and then topology. We are able to see that we have one spine and two leaves and one apic. Now for the lab, I have pre-initialized the setup, but however in your case you will do the fabric membership. That is, the setup of the spines and leaves will be done from the very basics. So you will go to the fabric membership. Now all those nodes pending registration will be shown here. You will register them with the help of the apic, which is going to provide the dep IP address to those individual nodes from the IP pool range that you allocated during the initial apic configuration. So once you have registered your nodes, it's going to pop up here. Now there are actually two ways to register the node. You can do it with the help of the apic, or you can pre-provide the information with relevant to the specific node by specifying the serial number and all that. Suppose if you have a problem with a specific node, then you will be able to find it under the unreachable nodes. And all the nodes that are not managed by the fabric, such as let's say there is a legacy switch or a Nexus switch, that's going to pop up here on the unmanaged nodes because that is not managed by the apic controller. Okay, so we have seen the topology. In our case, it's going to be one spine, two leaves, and one apic controller. Yes. In this case, you see that the apic is not connected to the another leaf. But however, in the reality, the apic has this big 1445, which has this bond 0 ports, which is used to connect to the fabric. So we will run one cable from the bond 0 to leaf 1, and another cable from the bond 0 supports. So you will run another cable to the leaf B, but however it is always in the active standby configuration. So we will also explore about more of those in the theory, and side by side we will compare them with the lab. Now apart from understanding the topology, I'm going to take you to the fabric policies. Now the fabric policy is a place which is used to define policies for the entire fabric. As the name suggests, it is to configure the policies for the fabric. And access policies are those that is used to configure the access ports. Now these policy, the access policy is exclusively for the access ports. So you do it for the access to the endpoints on the leaves. So let's say there is a server that is connected to the leaf A. Now how do you want the configuration of the port that is connected to the server? So that's what the access policy is. So let us say you want to change the speed, you want to change the CDP or the LLDP, then you come to the access policies. There is also a set of a proper method to create the access policies. So first we will create individual policies, then we will combine them. So here are those individual policies. Now, let's say you are creating a policy for the specific interface. You're going to go to the interface. Here are those. So the policies will be individually created. Then we will combine those policies, those individual policies, into a policy group. Now if you see here, you got this policy group. Now that is for the spine interfaces. You also have policy groups for the leaf interfaces. So we will combine those policies into the policy group and apply them to a specific interface. Let's say Ethernet 1/1, Ethernet 2/3. So we're going to apply that policy group to the specific interface. There is a benefit. We are not going to apply individual policies. Now that may consume time. So we are grouping them all together and applying them on the specific interface. Now you apply the policy group to the interface using the profile. So we saw about the policies and the policy groups and then the profiles. Then finally, you will point out to the specific leaf on which this interface is going to be present. So you will point it out to the leaf A or leaf B or the spine. Now this is the access policies. Apart from that, so this is at the underlay. This is for the the actual physical setup of your fabric. And then we have the tenants. This is very important, because in the tenant that we will create our own tenant. That the tenant is a place that acts like a container for you to administratively separate your domain from the other tenants. Now this is how we achieve multi-tenancy in the ACI. So as you can see, I have here many networking constructs such as the bridge domain, VRF, layer 2 outs, layer 3 outs used for the external connectivity. So let me go here to the application profile. Now this is where we will create the application profile within which we will create our EPGs. Now let me create an application profile here. Let us call it sample application profile. Now as you can see, while creating the application profile itself, I can create those EPGs here. But however, in order to create an EPG, a bridge domain is mandatory. So which means you have to have a bridge domain configured before the EPG. Now the bridge domain itself could be, it can be created independently, but however, the hierarchy is you have to map it to a VRF, a routing instance. So we create the VRF and then the BD and then map it to the EPG. In order to create the EPG, you have to have the application profile. The EPG is our core because the contracts are applied based on the EPGs. So we have to understand what these endpoint groups are, and then we can clearly understand how the contracts are being applied, because ACI is a zero trust model and the policies are to be configured to apply the traffic, to allow the traffic. You have to whitelist the traffic, or otherwise it is a zero trust model. It's not going to allow any traffic to move through. Therefore, it is mandatory, it's of paramount importance that we understand the EPG is working, so that we can understand how the contract and the traffic can be allowed. So the ACI is application centric infrastructure, which means the emphasis is on the application, and that is achieved by the application profiles. So the EPGs are the core of the ACI knowledge. So then while learning about the contracts, we will see how the contracts are applied with something called PC tag. Okay, I'm going to show you that value here. Let me quickly create an EPG. Oh, sorry, like I mentioned, you see, it needs the bridge domain to be created earlier. I haven't had the bridge domain yet, so I'm going to go to the bridge domain. Let me quickly create a bridge domain here. Okay, let me call this sample BD. So here you are seeing the forwarding options. Now here it is set to optimize, but however you can custom this, which is when we will talk about the layer 2 unknown unicast and the multicast threading, endpoint retention policies. ART threading could be enabled, which means you can make the ART threading to be unicasted, like I spoke on the introduction. The ART threading could be unicasted also. So those configurations are made in the bridge domain level. So I'm going to go next. So the unicast routing is must when you want the subnet connected to the BD to be routed. So if you don't have this unicast routing enabled, then you will disable the gateway for the subnets connected to this BD. Okay, now I have a BD, so I'm going to go back to the EPG. Okay, let me call this sample APG. Now these are all important options. Intra APG isolation, which prevents the endpoints within an APG to talk among themselves, because by default this is unenforced, and therefore all the endpoints present within the same APG can talk to each other. So there is a concept called the preferred group that is enforced in the VRF. We will see how that works. And here you see the bridge domain, that is must. So I'm going to have this one is what I've created, the sample BD. As you can see, it belongs to the sales tenant. Now apart from that, the common tenant, see that the default bridge domain belonging to the common tenant is visible. That is a very good use of the common tenant we have in ACI. It is the only tenant which shares resources with the other tenants, and there is a specific purpose behind it which we make use of. So we'll also see that during the class. Now I have mapped it to the sample BD. Let me scroll down. Okay, now my EPG is ready. The reason I created this EPG endpoint group is to show you the PC tag. Let it load. Okay, here we are. You can see the PC tag. This 49153 is allocated by the apic to this EPG. It is with this number, which is actually called the source class. This is embedded inside the VXLAN encapsulation header. So whenever the packet moves from the leaf node to another leaf node, the VXLAN encapsulation header holds this value inside the source class. And it is with this value the contracts are being applied at the fabric level. Yes, to be clear, at the fabric level we need it inside the VXLAN header, but however at the local leaf for the policies to be enforced, this PC tag will be learned locally on the leaf itself. Now that information, how the leaf gets to learn all these things, those are for the class, because it's you have to got it to understand it in detail, because there are multiple types of VLANs we have here. And the broadcast domain itself is not the VLAN like how we have in the traditional network. It's now restricted to the BD. So the use of VLAN is totally different here, and there are multiple types of VLANs we have here, like the FD VLAN, BD VLAN, PI VLAN. So we will explore on those different types of VLANs that we have in the ACI. So the reason I came here with the APG is to show you that we have something called PC tag that is used to apply the contracts between the various APGs endpoint groups. So that is the importance of the tenant. However, for the VLAN, you got to go to the fabric and then the access policies, and you have the pools here wherein you can create the VLAN pools, vSAN. So suppose if you're dealing with the storage and the FC, then you got vSAN, and you also have the FC domain, the fiber channel domains. Now in our labs we will see how the physical domains are connected, the bare metal host is connected. Apart from that, we'll also see how the virtual networking domain, the VMM, in our case we will make use of this VMware. So we will see how the integration of this VDS switch is done with the apic, and how the apic policies can be pushed to the VDS, such as the allocation of the port groups and moving the VMs into the port groups automatically. So we'll also see those things. Yes, and apart from that, we have the controller information present in this system tab. Let it load. It's loading. Yes. So here I have the controller information. Now what we have here is a physical apic, but you can also have a virtual apic. Now the integration of a virtual apic with your environment is certainly a little different, so we'll also explore how that is to be done, and what is sharding, how the what is the recommended number of apics, and why it is to be in odd numbers. Now those are certain things that we will discuss in the class. So you have the audit logs, the faults, events, everything could be checked here in the, and also the system health could be checked in the dashboard and the system tab. Then all the AAA functions such as the authentication, accounting, and authorization. Now those are those policies, radius, TACACS, and local LDAP. Everything could be configured in the admin tab. Yes, rollbacks, import and export. Now, as the name suggests, you will be familiar with all these things, such as creating the scheduler for a specific function. Now, all this will be detailed in the lab. So we have like 21 labs, out of which half are to the Nexus. Now we will practice them here in the Eve. However, now apart from the event G, we have this AP controller in order to discuss about the ACI labs. So for the Nexus, we will, we have the VPC, we have the FHRP, we have the VXLAN, how it works with MBBGP VPN, and how it works with the flood and learn. We can also discuss about the OTV. So we will perform these things in the lab. Yes, get ready for your class. All the very best from pynetlabs. Hope you join the class. Yes, we'll be very happy to see you in the class. All the best then. Thanks then. Thank you. Bye bye.